What is hidden in the darkest and the coldest place of the solar system? Why is the moon of Neptune, the god of sea, is so mysterious? What is hidden in the Kuiper belt and why Triton, the moon of Neptune, will eventually fall inside Neptune? Answer of all these questions you'll find here in this video. You are watching Cosmos, and today we are talking about Triton, the largest moon of Neptune. From the vast distance to the Earth, there exists a frozen world, totally bizarre and abnormal to us. Once maybe the giant of the Kuiper belt is now tied with the gravitational force of sixth gaseous giant of the solar system, Neptune. And the frozen world we are talking today is Triton, largest in the 13 moons of Neptune and seventh largest moon in entire solar system. Triton is the largest moon of Neptune. It was discovered on October 10, 1846 by British astronomer William Lassell, just 7 days after the Neptune itself was discovered. NASA's Voyager 2 is the only spacecraft to fly past Neptune and Triton. It found Triton is 200 times bigger than all the moons of Neptune combined. Its diameter is 2,700 kilometers. Triton rotates once on its axis in every 5.9 days, which is the same time which it took revolving around Neptune. And each of Triton's seasons, like those of Neptune's, last nearly 41 years, or 1/4 of the Neptunian orbital period. Triton's orbital tilt and its axial tilt of 30 degrees with respect to the Neptunian orbit combine in such a way that the moon's poles alternatively points toward the sun, much like in the case of Uranus. Now, why we consider it the most bizarre moon in the solar system? Because it revolves around its planet Neptune in retrograde orbit, which means unlike all the other moons of the solar system, Triton revolves opposite to the direction of Neptune. By considering its size, orbit and characteristics, astronomers believe that Triton was never be the moon of Neptune, but it was the giant of the Kuiper belt. They think Triton was maybe the part of a binary system in which the two planets revolves around their center of mass. Like other moons of Neptune, Triton orbits nearly a circular orbit around Neptune. In other words, we can say that eccentricity of Triton is very low. The one thing that attracts most people about Triton is it is very similar in size, composition and behavior to the dwarf planet Pluto. Maybe Pluto could be the next binary object of the Triton. Who knows? Triton and Pluto both have thin atmosphere of nitrogen and both have similar surface materials. The photos we have received from the Voyager 2 spacecraft shows there are similar reddish patches around the surface of Triton and Pluto. The naturally reddish patches around the both objects thought to be the result of methane ice turning into tholins by the ultraviolet rays of the sun. Like our moon, Triton is locked in the synchronous rotation with Neptune. One side faces the planet all the time, but because its unusual orbital inclination on both polar regions takes turns facing Sun. Triton has a sparsely cratered surface with smooth volcanic plains, mounds and round pits formed by the icy lava flow. Also, Triton consists of a crust of frozen nitrogen over an icy mantle believed to cover a core of rock and mantle. It has density twice the that of water. This is a higher density than that measured for almost any other moon of any other planet. That shows Triton contains more rocks in its interior than the icy satellites of the Saturn and Uranus. Triton has a thin atmosphere, contains mainly nitrogen with a small amount of methane. This atmosphere most likely originates from the Triton's volcanic activity, which is driven by the seasonal heating by the sun. Also, Triton, Io, and the Venus are the only bodies in the solar system that are known to be volcanically active at present time. Also, Triton is one of the coolest objects in our solar system. It is so cold that the most of the Triton's nitrogen is condensed at first, giving its surface an icy sheen that reflects 70% of the sunlight that hits it. NASA's Voyager 2 is the only spacecraft to fly past Neptune and Triton. It found surface temperature minus 235 degrees Celsius. During its 1989 flyby, Voyager 2 also found Triton has active geysers, making it one of the few geologically active moons in our solar system. During its flyby to Triton, Voyager 2 flew within 40,000 kilometers from its surface. On its flyby, it found a sufficient amount of frozen nitrogen sublimates, which means it passes from solid state to gaseous state directly to form tenuous atmosphere having a near surface pressure less than 0.002 bar. Within the polar cave region, numerous darker streaks provides evidence of the surface winds. At least two of the streaks and perhaps dozens are the result of the active geyser-like plumes seen erupting during the Voyager 2 flyby. Nitrogen gas escaping through vents in the overlying ice carriers in train dust is then transported downwinds as far as 150 km. The energy source and mechanism for driving these plumes are not yet well known, but their preference for latitude illuminated vertically by the sun had led to conclusion that the incident sunlight is an important factor. And near the equator on the Neptune facing side of Triton exist at least two and perhaps several frozen lakes-like features with terraced edges. The terracing is probably the result of multiple epochs of melting, each successive melt involving a somewhat smaller patch of ice. Some of the terrace cliffs rise more than 1 kilometer high. Even at Triton's low surface temperature, nitrogen or methane ice is not strong enough to support structures of that height without slumping. Astronomers assume that the underlying material in these structures is water ice, which is much rock-like at low temperature. Although no direct evidence is seen yet, a thin veneer of nitrogen or methane ice could effectively hide the spectral signature of water ice. It is thought that Triton's surface cooled faster than its interior and formed a thick outer layer of predominantly water ice. As subsurface water subsequently froze, it expanded, fracturing the outer layer and flowing through and filling the cracks. That's why the crater impact on the Triton is replaced by the ice, so it looks smooth and shiny. The intersecting fractures visible in the Voyager images of Triton's surface providing strong corroborating existence of water ice inside this moon. However, one day Triton will end, because it is coming closer and closer to Neptune. 3.6 billion years later, Triton will pass Ross limit, a minimum distance a large body can approach a planet without becoming overcome by its gravity. After this, Triton will torn apart and probably it will make a huge magnificent ring around Neptune, similar as we see today in Saturn. Thanks for watching. We will meet again in another journey of cosmos. But for that, you make sure you have subscribed Cosmos. And if you like it, press the like button and don't forget to write comment about your thoughts about space and astronomy. See you next time.